In this video, I'm going to be discussing how we can simplify expressions that have fractional exponents. So fractional exponents look like this. So instead of just integers, you have fractions. So it'll be something like a to the 2/3 or b to the negative 1/5. It'll be expressions that look like that. So let's say we have the number 16 raised to the 3/2 powers. So there's a few ways that you can do this. So one way is that if you have fractional exponents, you can rewrite them in terms of roots and powers. So we have the general form over here, or if we have a raised to a fractional exponent of m over n, this is the same as writing a raised to the nth power to the nth root, which of course is the same as writing the nth root of a raised to the mth power, which is one of the rules that we learned previously. So that what you can do is you can rewrite this as 16 raised to the 3rd power under a square root. And this is the same as writing the square root of 16 raised to the 3rd power. Well, the square root of 16 is just 4. And then 4 raised to the 3rd power gives me 64. Another way that you can do this is to split this number up into products. So this is the same as me writing 16 to the 1/2 power times 16 raised to the 1st power. Well, 16 to the 1/2 power is just the square root of 16. So you have 16 times the square root of 16. The square root of 16 is just 4. So I have 16 times 4, which gives me 64 also. Whichever way you want to do it, both of them are valid. So let's say I had 64 raised to the negative 2/3. So remember the rule for negative exponents. This is the same as me writing 1 over 64 to the 2/3 power. And I can rewrite the denominator as the cube root of 64 squared. And then I can rewrite that as 1 over the cube root of 64 raised to the 2nd power. So the cube root of 64 simplifies down to 4. So I end up with 1 over 4 raised to the 2nd power. And then finally, this gives me 1 over 16. Let's say that we had 3x to the 2/5 power times 2x to the 1/2 power. So again, the rule for multiplying the same base with different exponents stays the same, even if we have fractional exponents. So 3 times 2 is just going to give us a 6. But then the x to the 2 over 5 times x to the 1/2 is going to give us x raised to the 2/5 plus 1/2 power. And this comes out to 6 times x to the 9/10 power. So this answer is fine, but if you want to rewrite it in terms of roots and exponents, you would have 6 times the 10th root of x to the 9th. Both of these are valid. So let's say you had x minus 1 raised to the 1/3 power times x minus 1 raised to the negative 1 over 4th power. So I can rewrite the second term with a positive exponent by placing it in the denominator of a fraction. So when I do this, I end up with x minus 1 raised to the 1/3 power on the top over an x minus 1 raised to the 1/4 power on the bottom. So notice how the exponent sign changed whenever I place it in the denominator. So since these have the same base, I can use the rule that if I have one base raised to one power over the same base raised to another power is equal to the base raised to the difference of the powers. So when I use this here, I end up with x minus 1 raised to the 1/3 power minus 1/4. And then this gives me x minus 1 raised to the 1/12 power. Or if you want to write this as a root, we have the 12th root of x minus 1. Both of these answers will work. So as you can see, the rules for having fractional exponents remains the same as the rules if we had integer exponents. It's just you have to use the operations surrounding combining and multiplying fractions in order to perform these properly. But the methods are the same thing as if you had integer exponents. So I hope this video was clear and was helpful in doing some examples and practice with fractional exponents. And I'll see you for the next video. Thanks for watching.